Hello friends. In today's question, two men are walking along a horizontal straight line in the same direction. The man in the front walks at a speed of 1 meter per second and the man behind walks at a speed of 2 meter per second. A third man is standing at a height 12 meter above the same horizontal line such that all three men are in vertical plane. The two walking men are blowing identical whistles which emit a sound of frequency 430 Hz. The speed of sound in the air is 330 meter per second. At the instant when the moving men are 10 meter apart, the stationary man is equidistant from them. The frequency of beats in hertz heard by the stationary man at this instant is. So this question is based on the Doppler effect, but here the observer is in the vertical plane as compared to the source of the sound. So let us draw a little bit of rough approximate figure for the question. So we have two sources. Let this be source A and this is source B, and they are walking in the same direction. So B is walking with the speed of 1 meter per second and A is walking with the speed of 2 meter per second. And it is given that the observer is stationary and it is somewhere here. And when the distance between A and B, that is source of sound, is 10 meter, the observer hears a beat frequency. Okay. So you can say that the distance, this will be over 5 meters and this will be also over 5 meters. And it is also given that the observer is at a height of 12 meters. So we have to find out the beat frequency, or beats rather, heard by the observer. So let's start with the given information, and it is given that specifically when the observer is hearing the beat, we are given that two men are at the distance of 10 meter. Two men A and B, they are at a distance of 10 meter apart, and the observer it is at 12 meter above the horizontal line. Of the horizontal line. And the observer is stationary, and these two men are the, you can say, source. So source are moving along the horizontal line and the observer is stationary on the vertical plane. So we can find out the distance between the men and the observer, and that will be coming as 13, and this will be also coming as 13. Let us call this angle as theta and this angle also as theta. So we can use the Doppler effect, and the standard equation for the Doppler effect, it is given as the Doppler effect equation, which gives us that the applied frequency f prime will be equal to f, and this is our Vs divided by Vs minus plus and velocity of the source. And in this case, we have Vs is the velocity of the sound. We can say Vs is the velocity of sound, which will be our 330 meter per second. And V source is the velocity component of source along the line joining the source and the observer. So here V source is the velocity component of the source along the line joining line joining source and the observer. Source and observer. So in this particular case, or in this question, this plays a very important part. That is our V source. So let us find out this V source, what will be the velocity component. Velocity component along line of sight. And in this particular question, we have that the source, which are our men, they are moving along the ground basically. Source is moving along the ground, and the observer is above them. And therefore, the effective velocity component along the line of sight depends upon the angle theta. Depends on the angle theta, which is between the man's motion and the line joining the man and the observer. So we can write the formula that cos of theta will be equal to horizontal separation divided by distance from observer. Horizontal separation is there 5, distance from the observer is 13. So we can find out the velocity component along the line of sight. Velocity component along line of sight. So for man A, we can write that VA, the velocity, cos of theta, its velocity is given as 1. So this becomes 1 upon 13 is equal to 5 upon 13 meter per second. For man B, we can write this as VB, cos of theta, and this comes to 15 by 13, sorry, not 15 but 5, and this comes as 10 by 13 meter per second. Now we can just modify the Doppler effect formula according to these two. So therefore now we can say the apparent frequencies so first let's write for man A. Or we can say due to man A, because of man A, you can write that f of A will be equal to, we have 1430, that the frequency of the source, frequency of sound is 330, and this becomes 330 minus, and its velocity is our 5 by 13. Therefore we get that our FA is approximately equal to 1431.7 hertz, and now is our for man B. So we can say because of man B, we can write that FB is equal to, frequency of the source will be same, that is our 1430, velocity of sound is 330 divided by 330 minus, and this is our 10 upon 15. So we can write that our FB, that apparent frequency because of the man B, is approximately equal to 1426.7 hertz. Now we are going to find the beat frequency, which will be a difference between the two apparent frequencies. So we can say beat frequency if we call that delta F, which will be equal to our FA minus FB. We substitute the values. Delta F is equal to 1413.7 minus 1426.7, and this comes close to as 5 hertz. So this is the beat frequency that is being heard by the observer. So this question was based on the Doppler effect with a slight twist because of the velocity component along the site, which we converted to cos of theta. This completes the question. Thank you.